Number 1 on the graphing calculator. So this one is a tank problem. It's a conical tank, so that means it's a cone. They give me the volume of a cone. They give me a rate, so that kind of implies to me maybe this is a related rate problem. They give me some information about diameter, which is going to tell me about radius. They tell me the height. So the first thing I'm going to do is kind of collect my thoughts. So this right here is the tank is filling with water at a rate of 180 pi centimeters cubed per minute. So that tells me dV dt is 180. I'm not going to write my units because there's no space there, but it's 180 centimeters cubed per minute, but actually it's feet. I think that if we call that feet, then everything else matches up. So feet cubed per minute. Alrighty. Now what I'm going to do is take the next sentence and turn it into a picture. So I have a tank like this that goes like that. I know that so it says that the radius or the diameter is 40. So I am going to label the radius as 20 because I find the radius to be more useful. They also give me radius there. And then they tell me that the height is 40. So one piece of information that I'm going to draw out from this that I will use later is that the radius, r, is equal to half the height. And I can make that conclusion because as the water goes down, right, those proportions of those triangle are that triangle is going to stay the same. For example, when the height is 20, then the radius is going to be 10. You should see that. You should understand that. That's kind of like rules from geometry. Okay. What else am I going to do? So, actually, the first thing I'm going to do based on that is change this. I'm going to change that one. Yep. I'm going to change this volume right here. So that says volume is 1/3 pi r squared times the height. They don't really talk about the dV or dr dt versus the, actually no, sorry. They tell me height 40, right? Let's see, if the diameter, then what, this is it. What rate is the water level rising? That is asking what is dH dt. What is the height changing with respect to dt. So dH dt is what we're looking for. So that's why as I go through and I do this volume equation, I'm going to use this substitution of r in for r squared there so that I have volume in terms of height. That gives me V equal to 1/3 pi times, what do I get? I'm going to write h over 2 squared times h. Simplify, I get 1 over, so I get 2 squared in the bottom, which is 4 times 3. So I get 12 pi times h cubed. Now I only have one variable. They give me height here, so and I do my derivative with respect to t. I have the height, and I also have the variable that I'm looking for. I'll have a dH dt. So that's v. Okay. So the next thing that I'm going to do is figure out. It says when there is this much water in the tank. So I need to know the tank isn't full when they're asking me this rate. Let me get rid of some of this blue. So did I use that yet? Leave that there. So that is going to help me figure out what the height is at that time. So I will come over here. over here and find h. So I know that this is the volume, so I can plug that in the left-hand side. 27 pi over 3 equals 1 over 12 pi times h cubed. So I cancel my pi's to start. Then what I'm going to do is I'm going to type that into my calculator, and I'm going to multiply by 12. It's really, I guess, 9 times 12. But, so I'm going to have to kind of manage. Well, that gives me, and then I'm going to cube root it. So that gives me h equals cubed root of 108. The 108 is 9 times 12, or 27 over 3 times 12. Okay, which is approximately 4.762. So I'm going to try to use the root 108 when I can, but it's good to know what that height is. It's about 5, right? Okay, so now I do the related rate part of this. So maybe I'll change colors. So here I want to derive with respect to t. That gives me dv dt. There's no power on that. I'm just deriving the left-hand side, that single variable with respect to t, equals, I get power roll in the h, that's 3 times h squared, but I'm going to multiply it by this guy at the same time. So that simplifies down to 1/4. The pi stays there. H squared is the power roll on the h cubed. And then I need to do the derivative of the inside, so I get times dh dt. Notice, boom, that is what I'm looking for. So I want to isolate that thing. Now, this is where I'm kind of like, everything's starting to fall together at this point. I know that, I'll go to my green, this is dv dt. I wrote that right there, right? So I'm going to plug that in for that. I know this is h, so I'm going to plug that in right there. And then I can solve for dh dt. That's all I got to plug in. So I'm going to get, go back to, maybe we'll do purple. So I get 180 equals 1/4 pi times root or cubed root 108 squared times dh dt. So some of you may have trouble solving at this point because of that cubed root squared thing. So where do we go here? I'm going to multiply by 4 and divide by pi. So I'm just going to type, well, 4 times 180, is that 720? I got 1 blank, so I got, I'm thinking revolutions around a, so I got 180, 360, 540, 720. Yep, 720. Over pi equals cubed root of 108 squared times dh dt. So the reason I stopped there is because I want to talk about how I'm going to plug this in my calculator. I obviously can't show you on the computer here, but I can talk about it. So what I would do is I would type 720 divided by pi and hit enter. I'll get a number. Now, I would type, doing this in the calculator may be kind of confusing, so I get some number, right? So, then I'm going to hit divide, and then I'm going to hit open parentheses, 108 to the 2/3 power. I know that that is how to evaluate those exponents. You could use other methods like using our cubed root button on the calculator, but that's not always going to work because maybe we'll have to do a 5th root at some point or something like that. Anyway, when I type that in, I get, so I'm dividing that number by that, I get dh dt is equal to 31.748 feet per minute. Hopefully you're good with that. That's all.